Okay, this is Math 105, Section 6.2. We're continuing with our right angle trig. And now we're going to look at a right triangle. Okay, so we start with a right triangle with, that should be 90 degrees, okay, with 90 degrees as one of its acute angles. Okay, and then we can do, when we do that, we can look at our trig ratios kind of in the same way we did with the unit circle, but now we're going to put them in relation to the triangle. Okay, and let me kind of explain that. Let's say this is the center of your circle, and this hypotenuse of the triangle is the radius. Okay, remember, now this is our angle is going to be between 0 and 90. It's going to be less than 90, right? It's going to be an acute angle, right? Because when we're in a triangle, the angles have to be less than 90 if one of them is a right angle. So the right angle is going to be here, and then the angle that we're looking at is going to be here or here. It's going to be one of the opposite angles from one of the other angles besides the right angle. Okay, so if this is the center of our circle, and this is our radius, think about this pxy. Kind of draw the parallels here. This would be our point pxy, right? Okay. And then this would be our y here, that opposite would be our y, okay? And then the adjacent to that angle would be our x. So that's kind of what we're doing, is we're kind of drawing parallels between the unit circle approach and the right triangle approach. Okay, so now remember, when we do any circle, actually we haven't talked about this yet, but when we do any circle, the sine of theta, or sine of t, is x over the radius. Sorry, y over the radius. Sorry, for sine. Okay. And the cosine of theta is x over the radius. Okay, so when we're in a circle that's not the unit circle, we have to divide by the radius. Remember, if we're on the unit circle, we just do y for sine and x for cosine, right? But when you have a circle with a radius of r, we have to divide by r for each of those. Okay, so that's kind of what we're doing here, is we're saying, okay, cosine of theta is, or let's start with sine of theta. Sine of theta is y over r, which is opposite of our hypotenuse. Okay, so our radius is, remember, this is our radius. If we think about this as being embedded in a circle, where a circle might go around like this. Okay, and this is our center, right? So we can say sine of theta is y over r, which is opposite of our hypotenuse. Okay, cosine of theta would be x over r. Okay, which is adjacent of our hypotenuse. And we're talking about these sides in relation to this angle theta. So the side opposite theta is this side. The side adjacent theta is this side. And then the hypotenuse is the hypotenuse. So we're looking at the other two sides of the triangle. And one is opposite this angle, and one is next to that angle. And we say it's adjacent. So that's how we get sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse. Well, the rest are just ratios, right? Cosecant is just a reciprocal of sine, so it's hypotenuse over opposite. Secant is just a reciprocal of cosine, so it's just hypotenuse over adjacent. Tangent is, now we could say tangent is sine over cosine, which is y over x, because the r's would cancel, so that should be opposite over adjacent. See, y is opposite and x is adjacent in this case. And then cotangent is just a reciprocal of that, so that's adjacent over opposite. Okay, so that's how we get those trig ratios, okay? And if you might remember the shortcut, SOHCAHTOA, with an H in there that's silent. Okay. So just to kind of show where that comes from, sine is opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse. Okay. And tangent is opposite over adjacent. So SOHCAHTOA is like a just an acronym for remembering these relationships. Okay. So remember CAH, so the H is silent. Okay, just remember the full names are signed with an E. cosine with an E, tangent, cosecant, secant, and cotangent. Okay, that's the full names of them. Okay. Now, when we have any two right triangles with angles that are similar, okay, the ratios are the same, okay, regardless of the size of the triangle. By similar triangles, we mean, like, let's say in this example, we have 3, 4, and 5, but if you multiply everything times 10, we get 40, 30, and 50. So we're expanding that triangle, to a larger scale by multiplying each of these times the same number. In this case, it's times 10. Okay, but notice when we do that, the sign is still going to be the same. Sine is opposite over hypotenuse, so it'll be 3 over 5, which is 3/5. Or in this case, it's 30 over 50, which is also 3/5. So it doesn't matter how big the triangle is. The triangle could also be smaller too, as long as it's a right triangle. Okay, so it's going to have the same trig functions if you make that triangle bigger to the scale of this one. Okay, also it doesn't matter how your triangle is situated. Like, it doesn't have to be in standard position, right? Like, here our angle's here and our right triangle's here, but it's not, you see, it's a little off. It's not like it's flat. It doesn't have to be. Okay, so let's say we have these three sides of the triangle, 2 square root of 5 and 3, and a squared plus b squared equals c squared. So sine of theta would be opposite over hypotenuse, which is 2/3. Cosine of theta would be adjacent over hypotenuse, which is square root of 5 over 3. Tangent would be opposite over adjacent, so that's 2 over square root of 5. Now here we should rationalize our denominator. So here we're going to multiply times square root of 5 over square root of 5, which gives me 2 times the square root of 5 over 5. Okay, and similarly for this one, this would be 3 times the square root of 5 over 5 by rationalizing that denominator. So make sure you rationalize your denominators for these. Okay. Okay. So what did we do? We didn't do cosecant. Okay. So remember, cosecant is the reciprocal of sine, which is 3/2. Okay. Secant is reciprocal of cosine, so 3 over square root of 5, which is 3 times the square root of 5 over 5. And then cotangent would be the reciprocal of tangent, so it's just square root of 5 over 2. Okay. So once we have sine and cosine, the others just follow, okay, as ratios or reciprocals. Okay, let's look at some special triangles. So certain right triangles have ratios that can be calculated easily from the Pythagorean theorem. Okay, so these are kind of refer to the things that we did in the unit circle approach, where we looked at certain angles. Like when your angles are the same here on the right triangle, we have two 45s, we have a 90, of course, as well, right triangle, right? That means these sides here will be the same, okay? So what we can do is say, let's make them 1. Okay, make these sides both 1. And then we have this. We have a squared plus b squared equals c squared, right? And then 1 squared plus 1 squared is 2. So 2 is c squared if you take the square root of both sides. We're just going to do plus, we're not going to do minus, because we're talking about a side of a triangle. So c is square root of 2. So that's how we get that square root of 2, just by taking a squared plus b squared equals c squared. Okay, so we start with saying these are the same. Let's make them both 1, just to be simple. Okay, so now we can take the sine and cosine and tangent of 45 degrees, which is pi over 4 in radians. Okay, let's also look at a triangle which has a 60 degree on one part, one angle, and 30 on the other. And they has to have to 90 because this third angle is 90, right? So now we have a 60 and a 30. So one angle is double the other. Okay, so here's 60, here's 30. Okay, when you have that case, the sides corresponding to this side and this side will be half of this side. Okay, so if see the right triangle we've created, this red one, the hypotenuse is going to be double the side that's adjacent to the 60 degrees. Okay, and that's kind of what we can do as a rule of thumb for 60-30. Okay, is that this side, the 60 degree side, is half of the hypotenuse. So make this 1 and make this 2, right? So now we have this. We have a squared plus b squared, we don't know what b is yet, we haven't solved it, equals c squared. Okay, so there's our c is 2 and a is 1. So we have 1 plus b squared equals 4, giving us b squared equals 3. Square root of both sides gives us b equals square root of 3. Okay, so that's how we get that square root of 3, just by using Pythagorean theorem. Okay, So once we know that this is half of this, this side next to the 60 is half the hypotenuse of the red triangle, then we can find the third side, which is the B, which is square root of 3. Okay, so that's how we find the 30, 60, 90 triangle. And then these are the ones we're going to use to do our trig functions using triangles. So remember, this 30 degrees is pi over 6, and this 60 degrees is pi over 3, and then the 45s were both pi over 4. Okay, so remember the first one we looked at with 45, 45. So this is pi over 4, this is pi over 4. So we have a 1, 1, and a square root of 2 in our right triangle. And then for our 30, 60, 90 triangle, the red one, okay. Now, you can also see how this happened, because when you have an equilateral triangle, okay, all the sides are the same, right? And then this is going to be 60 degrees, this is 60 degrees, and then this will be 60 degrees. So when you have a triangle where all three sides are exactly the same, you're going to have 60 degrees for each angle, okay? So what we did is we cut it in half. And when you cut it in half, this becomes 30 degrees. Now we're going to use 2 because we're going to cut that in half and make it a 1. So we decided to make a 2 here because we can make it cut in half and make it a 1. So that's how we get the 2 and the 1 more directly, starting with the triangle that is this with all the sides being the same, okay? So that's how we get the 2 and the 1. Okay, so now we've got 60 degrees is pi over 3, 30 degrees is pi over 6, and we can do our trig functions based on those. Okay, and now just bringing up the triangles from the previous slide, let's look at a table of how we find our sine and cosine. Okay, so 30 degrees, remember, is this angle, okay, which is pi over 6 in radians. So sine of theta is, now here our opposite is 1, right? Hypotenuse is still 2. So sine of 30 is opposite of hypotenuse, which is 1/2. Cosine of theta is square root of 3 over 2, adjacent over hypotenuse. Cosine of 30. Tangent of 30 is opposite over adjacent, so 1/2. Okay. I'm sorry, opposite over adjacent, so 1 over square root of 3. So that gives us square root of 3 over 3 if we rationalize our denominator. Cosecant, remember, is just 1 over 1/2. Cosine of theta is 2 over square root of 3 over 2. So secant of theta is 2 over square root of 3. So we just multiply the top and the bottom times square root of 3 to rationalize the denominator. And then remember, tangent was 1 over square root of 3. So cotangent is square root of 3 over 1. Okay, so that's 30 degrees. Now let's do 60 because it's in the same triangle. So we'll do 45 last. Okay, so 60, sine of 60 is opposite or hypotenuse, square root of 3 over 2. And remember, 60 is pi over 3 radians. Okay. Cosine of 60 is adjacent over hypotenuse, so 1/2. Okay. Tangent of theta is opposite over adjacent, so tangent of 60 is square root of 3 over 1. Okay. And then the rest are just ratios. So sine of theta are just reciprocals. So cosecant of theta is 2 over square root of 3, which is 2 times the square root of 3 over 3. Okay. Secant of theta is 1 over cosine of theta, which is 2. Okay. And then cotangent of theta is 1 over tangent of theta. So 1 over square root of 3 would be square root of 3 over 3. Okay, so that's how we do 60. Okay, and finally 45, we're going to use this triangle now. So we can use either of these angles. It's going to give us the same, but now 45 is pi over 4, remember. Okay, so sine of theta is opposite over hypotenuse, which is 1 over square root of 2, which reduces to square root of 2 over 2. Okay. Cosine of theta is the same thing. Adjacent is 1 also. 1 over square root of 2, so that's square root of 2 over 2. Tangent of 45 is opposite over adjacent, so 1 over 1. Okay. And then cosecant is 1 over sine, so that's 1 over square root of 2 just becomes square root of 2. And the same with cosine for secant. 1 over square root of 2 is square root of 2. Okay, and then 1 over 1 is 1 for cotangent. Okay, so that's how we do these angles using the triangles. Okay, we're only looking at 30, 45, and 60, right? Just like, for our unit circle, we only looked at pi over 6, pi over 4, and pi over 3, right? So these are, we'll have the same values for these, right? Okay. And just a quick note, calculators often give the values of sine, cosine, and tangent. Other ratios can be easily calculated from these by using the following reciprocal relation. So remember, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Yep. And just a note about the convention of how we write when we write a trig function. we follow the convention that we write sine of t, we mean the sine of the angle whose radian measure is t. So keep that in mind that that's radian measure, okay, if we say sine of t. Okay. So if we write sine of 1, that means sine of 1 radian, okay. So that would be about 57 degrees. So sine of 1 is about 0.841471 using a calculator, okay. If we want to look at sine of 1 degree, we would have to put the degree there, okay? And you have to make sure you're in degree mode in your calculator, and that actually gives us something quite different, 0.0174524, okay? So keep in mind, if you don't see degree there, it means radians. So this means radians, this means degrees, okay? Very different, right? This is 1 degree, this 1 radian is actually about 57 degrees, okay? So make sure you're in degree mode when you're doing this. Make sure you're in radian mode when you do this. Remember, that's the DRG button on your calculator. Usually it'll say DRG or degree. Okay, and this D would be referring to degrees. This R would be referring to radians, and then the gradients we don't worry about, so we don't use that. And this is like a 3-way toggle, so it'll toggle between DR and G usually. Okay. Okay. Also keep in mind that a triangle has 6 parts, 3 angles, and 3 sides. Okay, so to solve a triangle means determine all of its parts. Okay, so all 3 angles, all 3 sides. Okay, so the lengths of the 3 sides and the measures of the 3 angles. Okay, so let's start with this one. Let's say we have, okay, we're given one side here, we're given 1 angle, and that's it, right? We're not given the other 2 sides, and we're not given the other 2 angles. Well, we are given this angle, right? Because we know it's 90, right? So we can figure out this angle is going to be 60, right? Because they have to add up to 180. 30 plus 90 is 120, plus 60 would be 180. And we know if you have 30 in a right triangle, the other one's going to be 60. Okay, so it's clear that angle B here is 60 degrees. Okay. To find A, we need to look for an equation that relates A to the lengths of the angles we already know. Okay, so think about what, like sine of 30, right, is opposite of hypotenuse. Okay, and we know sine of 30 is 1/2, right? So we can say, okay, 1/2 sine of 30 degrees equals A over 12, which equals 1/2, because we know sine of 30 is 1/2. So that's basically what we have there, okay? And if A over 12 is 1/2, then A would have to be 6. Okay, so that's how we find one of the sides. Okay. And then for the other side, we can say, okay, cosine of 30 would be B over 12, right? Because adjacent over hypotenuse. So that's what we have here is cosine of 30 equals B over 12. So B is 12 times cosine of 30. And here, remember, cosine of 30 is square root of 3 over 2. So 12 times square root of 3 over 2 is 6 times the square root of 3. Remember, we can just cancel out the 2 here and the 2 there, and that gives us 6 times the square root of 3. Okay, the last type of problem we're going to look at in this section is angle of elevation and angle of depression, and how we can determine sides based on that. So when you look at something across, like directly across, like horizontally, you're creating a right triangle if you're focusing on something that's higher, right? Or if you're focused on something that's lower, okay? So you're kind of creating sort of a virtual right triangle when you do that. So we have an angle that's, if you're looking across, like say at a building, and then you look up at something higher up on the building, you have an angle of elevation, okay? Or if you're looking down across a building, then you look down at something maybe right below that, then you have an angle of depression, okay? But either way, you have this right triangle, which is formed by your lines of sight, okay, straight across this way, straight across this way, and maybe the side of the building, okay? And the same here. You're looking straight across, then you're looking down, and then you have the side of the building as kind of your third side. So you have a right triangle, and here's where your right angle would be, like right there, okay? Same here, it would be like that, okay? So that gives us our right triangle, kind of going like this, okay? You see that? Okay, so generally we're going to know this distance, okay, the horizontal, okay? And we might want, and we'll know the angle. So maybe we'll know the angle and the horizontal, okay? And we might want to find maybe this thing, the height, okay? Or maybe how far down it is, okay? So we might want trying to find this, and we know the angle and the side, right? Which we can do for any right triangle. Okay, so just to summarize, if the object being observed is above the horizontal, then the angle between the line of sight and the horizontal is called the angle of elevation. If the object is below the horizontal, then the angle between the line of sight and the horizontal is called the angle of depression. Okay, either way you have a right triangle. Okay. If the line of sight follows a physical object, such as an inclined plane or a hillside, we use the term angle of inclination. We're going to stick probably with angle of elevation, angle of depression for our purposes. Okay, so let's say we have this tree, okay, giant redwood tree, and it casts a shadow on the ground that's 532 feet long. Okay. Now, we talk about the angle of the sun. It's going to form an angle of elevation that makes the shadow go this way, right? So we can say, okay, so the sun's going like this on the tree, and it's going to cast a shadow over the tree that goes like this, 532 feet long, and then the angle of the sun, angle of elevation of the sun from the ground is 25.7 degrees, okay? So what we have is we have this side of a right triangle, and we have this angle, okay? And then this would be like the height of the tree would be our third side of that right triangle, okay? The hypotenuse would be your line of sight going up to the top of the tree, staring right into the sun, which is not a good idea, right? So we have a side and we have an angle. And what we can do is we can find the height of the tree by using tangent. Now here's kind of what just kind of to go off the side here, I'll show you what I mean. So here's our triangle, okay? We want to know the height, okay? We know that this is 532 feet, right? So I'll put that 532 feet. And then the angle here is 25.7 degrees, okay? Okay, so what we can use is, well, let's think about what we know and what we don't know, okay? We know this adjacent side, right? We want to know the opposite, right? And if you think of SOHCAHTOA, we know the adjacent and we want the opposite. So we should use tangent, okay? So think about which two you're using. You know, which one you know and which one you're trying to find. So look for the unknown. In this case, our unknown is opposite. We don't know the hypotenuse, so we wouldn't use sine. But we do know the adjacent, so we use tangent, because here's our adjacent side. Okay, and we know the angle, right? So we can say tangent of 25.7 is opposite, h, over adjacent, 532. Okay, and that's how we get our value for h. And here we'd use a calculator for tangent of 25.7. Now another way to look at this problem is, let's say the sun wasn't out, okay, it was cloudy. What you could do is you could also determine the height of the tree by saying, okay, let's go to the tree and we're going to walk so many feet away. So let's say we walk 532 feet away, okay, and then we take our survey equipment that we have and we aim it at the top of the tree, okay. Now what the survey equipment will tell you is, will tell you this angle of inclination. It's going to tell you the angle that you pointed up from the horizontal to aim at that tree, to view that tree. So it would give us the same numbers. So if you can think of it that way too, that maybe we go a certain distance, a measured distance away from the tree, aim to the top of the tree with our survey equipment and get this angle. And we'll have the same, let's say we have those same numbers, we can solve it in the same way using tangent. Okay. So we get h equals 532 times tangent 25.7, which is 532 times 0.48127, or about 256 feet. Okay.